Hi there, welcome to Group 88's Delivery Service Application Demo, which is a team project for the course CS6310 for 2022. And we're a team of 3 members, Dingyi, Chan, and I'm Kaijun. We have made 3 major modifications to the basic app that we built in our personal project. Those include 1 non-functional modification towards app scalability, and 2 functional modifications, which are solar-powered drones and Angry Birds. My demo here will focus on the non-functional modification. As our app becomes more and more popular, we started to consider how to scale up our application so that more and more people can use the system concurrently. In order to achieve that, we have made the following major changes. First, to convert the basic app into a RESTful service. Why RESTful? Since REST embraces the precepts of the web and its benefits, such as caching, redirecting, and forwarding, etc. But how can we utilize the benefit of redirection and forwarding? We decided to use Nginx, which is one of the most famous open source software of web serving, reverse proxying, caching, and load balancing. With the first 2 pieces of puzzles figured out, now we're able to send data via HTTP requests, which will be directed by the load balancer to different app containers. However, the data is only being cached within each app container, so that different app container would end up seeing just partial of the data without a unified data source. So here, MongoDB came in to rescue. MongoDB is used here as a NoSQL database to keep data persistence. Alrighty, enough talking. I think everyone's ready for the demo. There are a few important items I wanted to cover during my demo briefly so that you understand how our system operates. First, let's go through the README and find out what command that we need. Well, looks like it's very nice. We only need to run 1 command to run the whole app with Docker Compose. Let's take a very quick look at the Docker Compose YAML file. There are 5 containers being defined here: the load balancer, MongoDB, and the application via node 1 through 3. Basically, you go to the A5 folder and paste the command in. Essentially, it will start to build the containers. To save us time, I have the RESTful containers built up already. I'm only building MongoDB this time. And now it's started. And we can send a quick GET request to our HTTP host 80 port. So let me do that real quick. Nice, we get back. Welcome to the Grocery Express delivery service. Next thing I wanted to touch on is actually how to send a command via HTTP request. You can simply basically either go to your browser and type in the following URL. It basically includes the localhost port 80 and address is process command, the query param, whole input line equals to the original command line that you would input as if it's a local server. Or since I'm using IntelliJ, I can just send it via a GET request. I have Docker shown up on the right, and we click into the assignment number 5 cluster. It shows all the it shows all the logs on the right. If we clear the terminal for now and we send a make store request, what we should expect to see is nice. So on the left, we notice that we're getting back a 200 and saying, okay, change completed. And on the right, we notice that, okay, it's communicating with our MongoDB, and also at the end, the node 2 sent back, okay, change completed. So now you're curious, if we send the same command again, what will happen? So let's do that. Okay, on the left, we notice that, oh, this time we get an error saying store identifier already exists. And on the right, you notice that, oh, actually, it's a different nodes getting the request. It's node 3 getting the request, and it's sending back the error. And next time, we're running the display store command. And OK, node 1 gets a request, and it's displaying the command. And now we can run like sell item, sell different item, and we want to display the items. OK, on the right, we see node 1. It's displaying items, cheesecake, and pot roast here. Basically, this quick demo briefly proved that the whole kind of system, how it operates, and how the data is being processed and directed through our system. Hopefully that addressed your questions or any concerns regarding the scalability part of the demo. Now I will pass it on to my teammates for the upcoming functional demos.